Hi, let me show you around the game a little bit and give you two rules that'll help you understand where all those parentheses should go and what goes inside them. I'll put myself in the corner here just so you can keep seeing me, and we'll talk a little about the game. So we have all of these definitions. We define here a name called the title, and we'll define it as something in quotes, and anything in quotes we'll call a string. And we've got four definitions here, all of the same format. We have define, and then a name, and then some string. We have another kind of definition right below it where we define the background and the danger. These are images for the background and an image for the danger. This is the cat, the target is the cheese, and the player is the city rat. And again, we have define and then a name, and all of this stuff in parentheses makes a picture, makes an image. We'll call these pictures images from now on. And you wonder what's the structure inside here, where you've got this thing called scale, and that's a function, and you're scaling by half. And clipart URL is another function that just takes a URL and gives you the image that is at that URL. So this is actually a picture of the red-eye rat, as we call him. And we'll scale it to half its size, and that's going to be our player. We're defining the player as that. Here, when we're making things move, we've got a different kind of definition. Here we're not just defining a single value, but we're defining an entire thing in parentheses. We're defining three names. Update danger is the function. Old X and old Y are more names, more variables, and we'll see how those work later. But for now, let me just focus in on this center part here and the very center of that, minus old x11. We know that old x is a number because we're told that. Old y is also a number, but we won't worry about that right now. And I just want to take this center part and talk about it a little bit. So let's say that we have these parentheses around that center part, right? Minus old y 11, or old x 11 is what comes in here. And I want you to imagine that these parentheses are connected in a big old circle, okay? And let's say not the only thing in a circle doesn't have to be a minus. You see, it can be a make position, or it can be a rotate or a scale. All sorts of things come in parentheses. So in this case, it's a minus, but let's say it was a plus for a minute, okay? So maybe we have a plus somewhere in this circle, and maybe we've got a 4 somewhere in this circle, and maybe we've got a 5 somewhere in this circle. Probably, if we do whatever this means, and who knows what it means, we'll get a 9, right? Because the plus thing takes two things and adds them, and the plus thing we'll call a function, and the two things we'll call inputs. So the plus function will take two inputs and add them, and it really doesn't matter whether it adds 4 to 5 or 5 to 4, because it's the same thing, it's always 9. But let's change things around. So now what if this is minus? Now it matters, okay? Because 5 minus 4 is just different from 4 minus 5, right? One of them is 1 and one of them is negative 1. So we need a rule. The rule is we're going to separate the function from the inputs, and the inputs will go left to right. Okay? So let's go ahead and do that. Let's separate out the function and make the inputs go left to right. Okay, so we'll put the function in its own little place at the top of the circle. We'll say minus, and now we know that it's 5 minus 4, so now we know that it's 1 because the inputs go from left to right. Okay, but what if we were to, add another function in here and maybe another input? Okay, well, what would happen then? We can't have that. This is confused. It could mean 5 minus 3 times 4. It could mean 5 minus 3 times 4. And that's only if we're just keeping the inputs going from left to right. So it's good that we have at least that rule. Otherwise, we'd be really confused about the order. But maybe it's actually 5 times 3 minus 4, because we haven't said anything about the order of the functions. Okay, so we got to get rid of all of this confusion. Let's just talk about these two possibilities for now. The second rule that we're going to add is a rule that says that each circle has one function. Okay? Now, if each circle has one function, then we cannot have a circle like this. That's a no-good circle. Instead, what we'll want to have is 2 circles. So you can imagine, for example, one circle that is going to be this function, okay? It will have one little piece here. That's the 5 minus 3. That's going to be one circle. And each circle has one function, so that's the function. The minus is the function there, and we've got 5 and 3. Then we'll have the times here, and we'll have 4 on the other side. Let's choose another color and do this one. Okay? We'll have a big circle. Let's see if you can guess what's going to happen before I actually do it. We'll have a little circle. Okay, and we'll have 5 here, 3, 4. This will be a times, and this will be a minus. Okay, so these look very different. How do we translate them back into Scheme? Way we go back into Scheme, first of all, let's run this. We get our game, and then when we get rid of our game, when we actually close the game at the end, we have this new part of the window that wasn't here before that says all 46 tests passed. That's very comforting. And it has this little arrow that says that it's waiting for us to type. So the way we translate circles into Scheme code is like this. We'll start with the circle. Let me pick yet another color, maybe a darker color than that. So we'll start with opening the circle. And again, the parentheses are like the circle part. That's not a very good color. Let me just go back to black. So the parentheses are the circle part. And so I'll start with a parenthesis. Then the first thing is the name of the function, right here. That's the minus. Then I have spaces in between to keep the names separate. So I have a space, and then the 5. And then I've got another circle to open right here. So I'll go ahead and open another circle, then the name of the function first. That's times, then the names of the inputs from left to right. And notice at the very end, I close this circle, and I close this circle. So that's why there are 2. And you see how Scheme puts the gray boxes to show you what circles are closed and what circles aren't. And you're going to have to be careful about making sure that every circle is closed and that every circle has a function at the beginning. Okay, so what should this be? 3 times 4 is 12. 5 minus 12 is going to be negative 7. Yes, it is. Let's do the other one. Again, we'll start with the parenthesis, then the function at the top. And now the very first thing we have inside this, the very first input going from left to right, is a circle. So we'll start the circle. We have the function at the top, because that's always the very first thing. And now the inputs from left to right are 5 and 3. We close the inside circle. We're closing that one. And then we have a space and 4. And then we close the outside circle. And what should we get here? 5 minus 3 is 2. 2 times 4 is 8. Yes, it is. I hope that has helped you understand where all of the circles should go and what all the circles mean and where the parentheses are supposed to live. And just keep in mind these two rules. Inputs go from left to right, and each circle has one function.